So, I'm sorry to be late. Good afternoon, everyone. My name is Kimito Kawamura, speaking from Japan. It is a great honor to have this opportunity to speak in front of you all, and I would like to express my deepest gratitude to everyone involved in the Japanese pavilion. Today, I will talk about solid oxide fuel cell power generation by biomethane gas from wastewater treatment byproducts. So first of all, I will introduce my company. My company named Asahi Quality and Innovations Limited. The headquarters is the famous building in Tokyo, Japan. Asahi Group Holdings is a holding company of 4 business domains: alcohol, beverage, beer, whiskey, wine, and so on, soft drinks, juice, mineral water, sparkling water, coffee, tea, and food, yeast extract, baby food, and overseas. My company is an independent research subsidiary of here under Asahi Group Holdings. Oh, sorry. Another monitor is working now. Okay, here it comes. So, our family working international stores here. The beer, for example, here in Europe, 28 companies, 9,085 employees, and 15 factories. For example, in the UK, meantime, in Netherlands, Grolsch, Pilsner Urquell in Czech, and Nastro Azzurro, Italiano. And more Oceania and Southeast Asia and Japan. Total 203 companies, about 30,000 employees, and 76 factories, and over $20 billion sales every year. So many famous beer and so many people are our family companies. So, I'll talk about my study. According to Paris Agreement, our Asahi Group established medium and long-term goals with regard to climate change in the form of the Asahi Carbon Zero initiative. With Asahi Carbon Zero, the Asahi Group aims to achieve zero greenhouse gas emissions in Scope 1 and 2 and 3 by 2050, and reduce emissions by 50% Scope 1, 2, and 30% Scope 3 by 2030. This study is one of candidate development. I'm going to talk about my study for 3 steps as follows. First, we have to develop a process to remove poison of SOFC cell from biomethane. Solid oxide fuel cell is an electrochemical conversion device that produces electricity directly from oxidizing a fuel. Second, in order to confirm the reliability of the reforming performance, we planned a long-term fuel cell continuous power generation test in laboratory level. And the third, construct a 200 kilowatt power generation demonstration plant and evaluate a long-term power generation. So before I report on the details of the technology, I have made a 5-minute video that shows you the summary of our development. So, please enjoy it.
Demonstrated with the world's first technology, fuel cell power generation using biomethane gas. We at the Asahi Group recognize that water, agricultural products, and other gifts from nature are essential for our business. To ensure Earth's bountiful environment is passed on to future generations, we have set the Asahi Carbon Zero goals and carry out various initiatives for reducing CO2 emissions. One such initiative is the biomethane gas fuel cell system demonstration project. At our breweries, biomethane gas is obtained in treating wastewater from the brewing process. Earlier attempts to use this biomethane gas in fuel cells failed to achieve continuous power generation for long periods. The cause was the poisonous substances, impurities in the biomethane gas. These poisonous substances deactivate the fuel cells. Many companies have taken up the challenge, but there have been no reports of successful operation for over 10,000 hours. When we conducted a thorough study of all the poisonous substances in the gas derived from wastewater at our breweries, we identified sulfur compounds as the only impurities. We then developed a process for removing the poisonous substances down to the ppb level. As a result, we succeeded in 10,000 hours of continuous power generation in test operation. And now we are conducting a demonstration project using 200 kilowatt fuel cells. This is Ibaraki Brewery of Asahi. Let us look at the processes from brewing to wastewater treatment process and electric power generation with biomethane gas. Beer is brewed in these tanks. The wastewater from the brewery is collected at a treatment plant, and the biomethane gas generated in this treatment is stored in a gas holder. From there, the gas is sent to a refining process to remove the sulfur compound impurities. The refining process consists of 4 kinds of treatment. In the pre-processing, desulfurization with iron oxide reduces the sulfur content to around 1 ppm. Next is wet gas refining. In conventional wet gas refining, gas flows from the bottom into a tank packed with a resin filler. Liquid sodium hydroxide is sprayed from above for desulfurization. The problem with this method is the unstable contact between the gas and liquid. It cannot reduce the sulfur compounds to the required level of less than 0.1 ppm. We therefore adopted a new approach, filling the tank with liquid sodium hydroxide so that the gas passes directly through the liquid. The biomethane gas forms numerous tiny bubbles which rise to the top. As chemical reactions with the sodium hydroxide continue to occur, the sulfur compounds are reduced, and since the rise is slow, nearly all of them have been removed by the time the bubbles reach the top of the tank. The biomethane gas is then cleaned in water tanks. Next is dry gas refining using activated carbon. Finally, dehumidification is performed, completing the refining process. Using the biomethane gas that has been refined in this way to high purity, stable fuel cell power generation becomes possible. The test equipment is currently in operation, demonstrating the originally aimed for refining and power generation capabilities. The next challenge will be to try for 10,000 hours of continuous operation with this system. The Asahi Group aims to achieve zero environmental impact in its business activities and is working to leverage its proprietary technologies to create more environmental value in society. With this biomethane gas fuel cell system technology as well, we will continue to make improvements based on ample feedback, aiming for its widespread use in society.
Okay, thank you very much. Next.
Demonstrated.
More. Okay. From now, I will speak about the details of this technology. This is the first step of refining. The upper section is wastewater treatment process. Then the raw gas comes from methane fermentation reactor here to desulfizer here. This goes to number one. Number one data is here. Then after desulfizer, it goes to combustion line for gas engine or gas turbine, or our refining line here. At this point called number two. And the raw gas divided from combustion into line to our refining line. The gas flow into the bottle of caustic soda here into to the bottom and dispensed. After this wet refining, is number three, and flow into the dry refining. Inside of column filled with active coal to remove another poisonous components. And after detected value of the this gas, number one and number two is here. Then from the value of raw gas, only surface components remain as poison in our biomethane gas. Here, here, and here. So only surface components remain means only surface components should remove in our refining line. Next. At first, we measured main contents of biomethane gas for 5 times in 6 months. Each value of contents is not same, but tendency of the influence of gas is seemed to be same. The value of methane gas concentration rise up with refining process. Number 2, number 3, and number 4 here. But nitrogen and oxygen didn't change. On the other hand, the concentration of carbon dioxide rise down with refining here. It means carbon dioxide dissolved in caustic soda solution, and the hydrogen sulfate concentration extremely decreased here. This is clean biomethane gas composition for 1 year. It went well through 1 year. 2017 on December to February to November. Then this is hydrogen sulfate and siloxane and chlorine, all not detected. Poisonous components have not detected in this term. It goes very nice. This is the second method, over 10,000 hours power generation test. This is equipment for fuel cell setup. Anode gas comes from the top. Here, anode gas comes from the top to this area. And pure water comes also from top. Water comes top to carburetor and vaporization. The vertical cylinder lateral stripe type fuel cell, this 3 chips here as cathode. The mechanism of power generation shows in this figure. And at the start of power generation, we used commercial metan gas for the examination. First time commercial metan. When it became the stable generation, we changed metan gas from commercial metan gas to biomethane gas. This is a result of long-term power generation over 10,000 hours. There is a noise in the beginning. After having tuned, the noise disappeared, and continued power generation over 10,000 hours smoothly. Total generation hour was 10,319 hours, and the degradation was very low at 0.3% every 1,000 hours. This schematic flow diagram, this is schematic flow diagram of demonstration, 200 kilowatt power generation. Biogas comes from the gas holder, biomethane gas holder, and pressurized by roots blower here, and put it pre-processing tank here. Inside of pre-processing tank, there are iron oxide absorbent to remove hydrogen sulfate to under 1 ppm. This gas from the top and go to NaOH bubbler tank with pressurized by roots blower number 2. Inside of the tank of bottom line, there is a spurging nozzle which blows the biomethane gas into caustic soda. Once blown into the solution, biomethane gas shaped many tiny bubbles and start to move from the bottom to the top. While the bubble floats to the top, the carbon dioxide and hydrogen sulfate move from biomethane gas to caustic soda. After reaching to the top, the hydrogen sulfate almost disappeared. Cleaned biomethane gas moved to the next water bubbler tank and to the bottom. And there are photos connected to these block flow. The purpose of water bubbler tank here is gas washing, gas cooling, and gas less hydrogen sulfate to remove. The spurging bubble size in caustic soda is here, is smaller than bubble size of water tank. From the water bubbler tank, biomethane gas leads to cooling here, and water drain separated from high humidity biomethane gas. After drain separation, pressurized by the third roots blower and blow into the column, active coal column, and pressurized by the after the column, and the target of absorption of this active coal is another material for another hydrogen sulfate or something bad material. So the last section of dry gas refining is defumidification here by silica gel or similar material. Refining process was finished here. After that point, biomethane gas should be pressurized based on the demand of the fuel cell. Pressurized by gas compressor. The control should be done by SOAC control system. This is control room. This is a photo overview. This is the result of commercial scale refining data. Almost all data are similar as pilot scale data. The only difference is the concentration of hydrogen sulfate value. This time, the hydrogen sulfate value before refining was much higher, and value after wet refining already zero. It is very good result, but it means the load to the depend on caustic soda being high. This is a result of power generation. The graph on the left shows the amount of electricity generated by city gas here, and methane gas here. The amount of electricity generated by the fuel cell part is 208 kilowatt, while that of methane gas is 192.4 kilowatt. On the other hand, the graph on the right compares the fuel efficiency and shows that methane gas has higher efficiency than city gas. Methane gas, methane gas is higher than city gas. Methane gas is 51.4, city gas 49.5. Its efficiency. Although we cannot draw any conclusions at this time, methane gas with a concentration of about 89% shows the same amount of power generation as city gas. And also shows higher efficiency than city gas, methane gas. The evaluation will be finalized with the results of long-term continuous operation near future. Conclusions. We can narrow down the target poisonous components and removed. The only poison was hydrogen sulfate. Therefore, we could focus the refining process to hydrogen sulfate. 1 year old, it was clean. The long-term power generation over 10,000 hours was achieved. Based on the result, we can design the commercial scale plant and it ran good. Future prospects. We will challenge over 10,000 hours continuous power generation by this 200 kilowatt plant. We are going to release this technology widely in the society and push forward social implementation. Thank you for your kind attention. Finished.